Hello everyone, my name is Ryan Ridgely, and today I'm just gonna go over our discussion that we had this week, discussion 8, and this was on calculating averages. So before we get into this, I just want to kind of define what an average is. So an average is basically an even distribution of the sum of values over the number of values. So for example, just really quickly here, if we take 3 components and we add them all together, in this case 10, 15, and 20, we get 45. If we divide 45 by 3, we're going to get 15. So 15 in this case is going to be the average of this data set. Below, I've also expressed this mathematically, so the numerator being the sum of all of the components and n being the number of components. So that will be our quick mathematical expression of an average. So how does this kind of tie in with matrix multiplication? Because we have this expression that's given to us, m, which is the mean, equals 1 divided by n times the transpose of 1 times the matrix X. So really quickly here, I've just kind of defined some values, and we take 1 divided by 2, which is going to be the number of components. I have 2 right here, so 10 and 20 are respectively. And we're going to just do some matrix multiplication and then see what we get here. So if we do 1 times 10, that's going to be 10. Then we add 1 times 20. Now that's going to give us the sum. Once we have that, we divide it by 2, therefore giving us an average of 15. So we kind of have proven here that if you take these two values, add them together, divide them by 2, you will get an average. Now, we also have this other way of doing it too. So we have the mean equals 1 divided by n times the transpose of x times the matrix 1. So this will give us the same result, but the result's going to be transposed. So instead of a 1 by n matrix, we're going to be getting an n by 1 matrix. Same exact values, just expressed in a different way. So I have a little example here. So this is an n by 1. Now we have to explore why m computes the mean. So I kind of went over this a little bit, but basically an average, it has 2 requirements. So there's the sum, and then there's the division of the sum by the components. So having a matrix of 1 allows us to multiply each element by itself, and that will give us a sum, and then we divide that by n. So 1 divided by n will distribute those values evenly, therefore giving us an average. So what size will m be? Well, that kind of depends on which function you pick, but generally it will give us, if we decide to transpose 1, we will get a 1 by n matrix. You could see here, n has to be the same value as m in this case. And when you do that, you get the outside values. So the outside value is 1 here. The outside value of this matrix is going to be n. Therefore, you'll get a 1 by n. Say if you swap this and you do it with the other expression, you will get an m by 1 matrix, which is why back here we got an n by 1. So that is going to be the other option here. So it depends on which one you transpose, but you will get the outside values. So really quickly here, we just want to kind of make an argument for why these values are the same. So for this segment, I'm just going to pull up MATLAB, and I'm going to define our data set here. So we have our x, which is going to be price of the home, number of rooms, square footage, and whether or not there's a pool. I've also defined our matrix 1, and we can go ahead and just calculate this out and see what we get. So we have 1 divided by n times the transpose of 1 times x. Let's see what we get. So we get a 1 by n, and these are the values that we get, which are price. So this is the average price, this is the average room, this is the average square footage, and this is a percentage based on how many values, how many components have a pool. So 75% of this data set contains a pool. Now let's just go ahead and do the latter. Let's see if this works with transposing x instead of transposing 1. So we'll just do the same operation here, and we'll transpose x multiplied by 1, and we'll see what we get. So we get an n by 1, but we also have to transpose the answer. So let's go ahead and do that. So you can see here that we get the same exact answer. So we have just proven that these are equivalent operations and they will both give you the same exact answer. So let's just make some observations here. So we see that the price of the home kind of depends on 2 factors, really. It depends on the number of rooms and the square footage. So you can see here that the smallest room, number of rooms is 4. So that elicits the smallest price of $180,000. And then as the number of rooms goes up, we can see that the price goes up too. So 6 rooms elicits a price of $510,000. So there's a correlation there. As the number of rooms go up, so does the price. Also, the number of square footage, the amount of square footage also correlates directly to the price of the home. So the smallest house is going to be 1,300 square feet, and that's going to elicit the smallest price out of $180,000. As the square footage goes up, so does the price. We see that the biggest house has 2,100 square feet, and it elicits a price of $510,000. Now, we kind of have an outlier here because the pool does not directly indicate price. We can't really assume that having a pool will either increase or decrease because the cheapest house has a pool and so does the most expensive house. So we can't really make a determination there. We really need more data to make an assessment. So let's go ahead and compute the matrix and just see what we get. So we get an average here, an average price of $292,500. Pardon me, $292,500. The average room is going to be 5, number of rooms 5. The average square footage is 1775, and this right here, the last component is going to be a percentage. So 75% of the homes in the data set contain a pool. So how we get to that is because 0 means that there's no pool, 1 means there is a pool. When you average those together, you get a percentage. So this is our data set, and this is kind of representative of the small amount of information we have here. There's a couple of people in the discussion that definitely made that made some great points. For instance, the average price of a house in Chandler is actually north of $300,000. So we know that this doesn't represent all homes in Chandler, but it represents the small data that we have. And yeah, well, that's it. If you guys have any questions, you can send me a message on Canvas, and I hope that this helped you with your discussion this week.